Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about what is machine learning, and the plan is to have a series of video which progressively explains every concept that is there in machine learning with some hands-on. So the first in the series is a basic introduction to machine learning. So let's get started. First of all, even before we start talking about machine learning, we need to talk about artificial intelligence, what it is, because machine learning is a branch of artificial intelligence. So what is artificial intelligence? As the name suggests, it's an intelligence which is artificially induced, which means there are a set of technologies that are being built which will enable machines to think like humans or have the intelligence that we as humans have. So that's what AI is. So we are trying to solve problems by mimicking human intelligence. If you want to look at examples to understand it better, there are examples from our daily or day-to-day world. Things like ChatGPT. Things like Netflix. Why Netflix? In Netflix, we see a lot of recommendations coming based on what we have been seeing. That's an example of a machine learning problem where it is actually looking at the past data, understanding what the choices of the user is, and then recommending. Similar example can be Amazon, where when we purchase something, it does show us similar things, or based on our history, it will show up deals, etc. And Google Translate can be one example. So there are n number of examples, but these are the most common ones which each and everyone can relate to. Another term that is getting used very frequently these days is artificial general intelligence, AGI. What does it mean? So as of today, it's a theoretical state because our computer systems or our technologies have not reached that stage. So we call it a theoretical state. But essentially, AGI means that we want to reach a state where computers will exceed human intelligence. And computers have certain pros. We as human may not be able to remember everything, right? There is a vast amount of data that the computers can process at a very minimal time. With the advances in hardware, with the advances in technology, the machines are becoming more and more capable of storing and processing huge amounts of data. A human cannot possibly remember everything that has happened in the past or assimilate as much data as a machine can. But the advantage a human mind has is its intuitiveness. It can look at the context, it can make decisions based on certain times intuition, certain time their own intelligence. So there are pros and cons of solving a problem with a human mind versus a machine. But ideally, the state to which people are trying to go towards is a AGI, where the machines will exceed human intelligence. We may have seen multiple movies where this has been shown, but as of today, that's not a reality yet. Okay, now coming to machine learning. Since we got the background of AI, AGI and some context, it will be now easier to understand machine learning. So machine learning is a branch of artificial intelligence, AI. It's a branch of computer science, branch of artificial intelligence, which is focusing on building algorithms which will look at huge amount of data and try to solve the problem. So we will feed in data, lots of data. We will build an algorithm which can look at that data and think the way humans would, and it can predict outcomes. It can solve the problem for us, just like humans. That's machine learning. So the name also suggests that the machine is trying to learn and predict outputs. Okay, so that's like it is trying to imitate the way the humans learn, and it will keep on improving that accuracy. That's what machine learning is in a very simple term. Now, how does machine learning work? Let's look at it through three stages. The first stage is a decision process, which means a machine learning algorithm. What it will do, it will make a prediction or a classification based on the data that we are feeding in. So we are feeding in data, there is an algorithm which is running, and then there is an output which is nothing but a prediction or a classification based on the data that it was trained on or that we fed in. The second part is the error function. What does it mean? The error function means there has to be some function, some way to determine whether the model, the prediction or classification that the model did is correct or not, and how correct is it, how accurate it is. It really depends on the data that we keyed in. How is the data quality, is there a bias in the data, how correct is the data, how varied is the data that has been collected, what was the data on which the machine learning algorithm was trained. Based on that, and also the algorithm that we use, did we use the right algorithm? Based on that, we will see what is the output and the accuracy. And the third and the very important part is optimization. So we will build a model, we will key in data, we will build a model, we will look at the accuracy, but we will keep on iterating, improving. So that's the optimization process. It's an iterative, repetitive process. You will never get the things right at one shot. It is like building a model, checking the accuracy, then again going back to the data, re-looking at the attributes or features that we selected for the model. Were they correct? Were they the right ones or not? Was the data correct or not? And then we keep on improvising. So these are the three very broad level of categorization within how, just to look at how ML works: decision process, error function, and optimization. Now coming on to types of machine learning methods. We can categorize machine learning methods into four, very broadly, four categories, and within this we will have multiple things that we will discuss in subsequent videos. But just to have the context set, let us look at what these four things are. So the first is supervised learning. So as the name suggests, this is a learning that the machine is doing, but it is supervised. What does that mean? It means that the data that we are keying in to build that machine learning model, it's a labeled data set. So you are training the machine on a labeled data set, and then you are asking it to predict outcomes accurately. What does labeled data set mean? So it's something where, so we'll talk about supervised learning in far more detail later, but for us to understand now, label data set means you are already telling the machine that okay, these are the attributes in a data. Let's say there are 10-20 attributes that are present, plus you also have the outcome that you're trying to predict. Let's take an example. For example, we are doing a fraud detection. Now we already have a data where we have a set of transactions, let's say credit card transactions for multiple people, and now we are trying to predict which of the transaction can be a fraudulent one. So label data sets means I am giving this data set as a training data set to the machine learning model that I am trying to build, and in this data I also have the outcome. So I already know which transactions are fraudulent versus which are not. So I am kind of giving the machine a hint or a label data set where I'm telling that these are the transactions which can be fraudulent. Now the machine learns from this, and next time when you give it a data where the outcome is not present, the model will go through the data and predict the outcome for you. So that's the supervised learning, where we are giving a label data set and then we are asking it to do the prediction. Now the second category is unsupervised learning, which means we are not doing any supervision. We are asking the machine learning algorithm to go and figure out for itself. So it is like using algorithms which will analyze and cluster unlabeled data sets. So usually the unlabeled data sets or subsets are also called clusters. The machine itself will discover patterns or groupings without the need of human intervention. So if I give a very basic example, if there is a child, we give the child a set of toys, right? And we do the segregation of, let's say, all the red ones at one place, all the yellow ones at one place, and tell the child that these are red, these are yellow. And then we give one toy to the child and ask him or her to put it into the right bucket. So they know already what is yellow, how does it look like, they know how does red look like. So they can actually look at the object and categorize it. This is supervised learning, because we already told the child that these are yellow, these are red, and then we are asking the child to put the new toy into the correct bucket. That's supervised learning. But if I just give a heap of toys to the child which has all colors, yellow, green, red, and ask the child to do the segregation on its own, then that is an unsupervised learning. The child has to now discover patterns, understand, and then do the classification or segregation. That's the difference between supervised and unsupervised learning. There is a third category which is semi supervised learning. Now, what is semi supervised? It is a combination, we can say, of supervised and unsupervised learning. So when we do the training part of it, so in any machine learning algorithm, when we try to build it, we have a training data set on which we are training the model. Then we will have a validation data set on which we will try to validate whether the model was built correctly, and then will come the actual data set on which the machine will start doing predictions. So during the training, we give a smaller label data set to guide the machine, and then classification, and then we ask the machine to do feature extraction from a very large unlabeled data set. So it's a combination of both supervised and unsupervised learning. The last category is reinforcement learning. So if you look at these terms, the name itself will give a hint of what it means. So reinforcement learning means the machine learning model is similar to supervised learning, but this algorithm hasn't been trained using sample data. The model learns as it goes by. So we are not training it on a labeled or unlabeled data set like we do in supervised and unsupervised. So reinforcement is like a supervised learning, but we are training it on the go. So it is learning on its own by trial and error. So what is done? A sequence of successful outcomes will reinforce and develop the best recommendation. So it is learning on the go, and the more accuracy it gets, or the more correct prediction it does, it keeps on learning. So it's a reinforcement learning type of machine learning.
So let's quickly summarize what we have seen till now, how a ML model works. So this is a very simple diagram to depict whatever we spoke about till now. So what is happening here is there is input data which we are keying in into the ML model. The ML model is getting built on this input data. Now the input data has two parts. One is the training data and one is the validation data. Both of these are important because what is the training data? The training data is the one which is getting fed to build that ML model. Now, it is extremely important to keep in mind how good that training data set is. The accuracy of the model will depend upon what kind of data are we keying in, whether the data quality is good, whether it is a large sample set or not, whether it is unbiased or not. So there are multiple things to look at to create that training data set. What is the validation data set? Once the model has been built, we will validate how good the model is working, and that will be done on the validation data set. So it's like a 80-20 kind of a thing where you have a data set, you split it up, 80% maybe to train the model and 20% is your validation data set on which you already know the outcome, so you're going to predict how your model is working. So that's all about the input data. Now this input data is keyed into the ML model, which is now predicting the output. Then there is this piece where we are judging the accuracy of the model. The accuracy judgment is done, and based on that we keep on doing this iterative process of optimization. So this is how the whole process will work. There are many nuances within this, but this is the most simplistic view to look at.
So now let us look at the advantages of using machine learning algorithms. So first advantage is that accuracy can be much greater than what humans could do. So if there is a use case, let's say of fraud detection, the way humans will look at it versus if we can feed in a lot of past data and the predictions into the machine and build a reliable and accurate machine learning model, the output prediction will be much more accurate. Similarly, the operational cost will go down and we will have greater efficiency because we have built the model once, ensure that it is accurate. We can rerun and even we can give the feedback back to the model and refine it. So that way the operational cost would be lesser, accuracy will be higher. We can do a lot of increased personalization in terms of the services and products that we provide. It can benefit us by having improved decision making in certain situations. Also, it is very quick to generate new content, text and images. ChatGPT can be one of the examples where it is so quick to give us the response back, because as a machine it can actually scan through humongous amount of data and come back in a very short time. So in all, machine learning is useful to have more efficiency, accurate decisions, reduce the cost, operational cost. Now when I say accurate decisions, it comes with a caveat that the data that we trained the model on was actually accurate, and it was from a large sample set. We have spoken about these points, but I'm just reiterating the fact that the model is as accurate as the data we gave in. So if we make sure that the data is clean, unbiased, the data has been taken considering different scenarios, the model will be much more accurate. Similarly, nothing comes with all pros or advantages. Let's talk about what are the challenges. Challenges, one of the challenges which everybody fears in the world as and when use of AI and ML is growing, is loss of jobs. Would machines replace humans? Not really. They will not replace humans, but yes, they may cut down jobs because machine can do much more. There is always a potential for bias or discrimination. As I said, if the data on which we are training it is biased, not correct, the model will also be biased. If we key in the data, if we give the data to the model which has considered only few scenarios, or it is itself biased, the model will be biased. There is a possibility of cyber security threat because it's all digital. We are running the model online, so there are chances of cyber security threats or concerns, so we have to be extra cautious. There may be lack of transparency as to how the decision was arrived, because it's a machine learning model. So if there is a lack of transparency in decision making, sometimes it may result in less optimal solutions. There can be a potential threat of having misinformation, or we can inadvertently violate laws and regulations. Depends on how we are collecting the data. Are we displaying something confidential? So it really depends on the creator of the model and the person who worked on creating the data the model is trained on, has to take care of how the model has been built, what kind of data is it going and scanning, is it violating any laws and regulations. But all in all, there are some challenges which are to be kept in mind while building the machine learning models. Okay, so this was all about machine learning in a nutshell: pros, cons, the very basic fundamentals. I hope this video has helped you. In upcoming videos, we'll talk more about each of the machine learning models, supervised, unsupervised, and even go deeper into those. So keep liking, sharing, and subscribing to the channel. Thank you, everyone.